This is Tess Moore, and the postmortem change that I chose for this project is decomposition. So, decomposition is a natural process that starts occurring after death. It's tissue breakdown. So, it's splitting proteins, it is reducing body structures that were once complex into simpler compounds. It will block or damage blood vessels. It is negatively affected by hydrolysis, so it is careful to note that hydrolysis will further break down those proteins in the body. It is going to release nitrogen and shift the body's pH from acidic to basic, and this alkaline state is a much better medium for bacterial growth. So decomposition is a chemical change. Although we can see and smell and feel that a body is experiencing decomposition, it's breaking down the body tissues, which is accelerating those postmortem changes. But it's a cell self-digestion. It's bacterial activity. It's breaking down biochemical compounds. So it is a chemical change because a physical change does not change the chemical composition of the body. There are environmental factors that will speed up or slow down the process of decomposition. So moisture is going to speed up the process because it's going to spur bacterial growth. Dry or cold environments are going to slow down decomposition, and that putrefaction is going to occur with moisture. So being in a humid climate or in water that isn't freezing, it is possible to completely stop the decomposition process, and that is going to be with freezing temperatures. So in a below 32 degrees Fahrenheit, which is the point of freezing, the decomposition will stop, but only for as long as it is frozen. So it's going to halt the breakdown of molecules and structures. The rapid decomposition is going to be caused by temperatures between 70 to 100 degrees Fahrenheit because it is increasing the chemical reactions. So, refrigeration is important. So, for embalming, the purpose is to preserve. So, we're trying to preserve the tissue. Drainage needs to occur because hydrolysis is further breaking down the proteins in the body, and water is the primary vehicle for embalming fluid. So we have to be careful and make sure that those solutions are balanced, because using the aldehyde compounds, alcohol compounds, and phenolic compounds, we're trying to create a protein coagulate to delay decomposition because those substances are going to be resistant to hydrolysis, not immune to hydrolysis, but resistant to stall the process. We'll also deodorize amines. So formaldehyde is going to deodorize the amines that are caused by decomposition, because those are a product of decomposition formed by the proteins and the nucleic acids, and they're creating a very strong and unpleasant scent. So a higher concentration of embalming solution is going to be required. And that preservative demand is going to be higher. So, in the simple terms, we can say that the equation AB reduced to A plus B can be thought of to describe decomposition, because it's taking the complex compound of AB, reducing it to the simpler terms of A plus B. So what we're trying to accomplish with embalming is cross-linking. So cross-linking those broken proteins that are being caused by decomposition, cross-link those broken proteins in the tissue, put them together to form new chemical compounds, because that is going to delay the process, creating those compounds, because they are going to be an unfit food, basically, for microorganisms. So using chemical solutions to cross-link the proteins, being careful with hydrolysis, making sure that we are replacing the body's fluids, because the body's fluids are continuing the rate of bacterial growth, and avoiding certain environmental factors. Thank you.